Hello everyone, welcome back with me Kunsha dan Olivia from SMK Negeri 1 Lemah Abang. This time I want to present material regarding VLANs and trunking. The sub-materials we will cover include what is a VLAN, VLAN configuration, creating a two-room typology, learning about trunking, testing pings between rooms, learning about allowed trunks, creating a three-room typology, trunking on MLS or multi-layer switch, dynamic trunking protocol or DTP theory, practicing DTP, understanding untagged versus tagged, and finally, native VLAN configuration. Uh, in this previous video, we learned about broadcast domain. Now, I want to explain VLANs or virtual local area networks. Before we begin, I want to explain something. Let's imagine we have a room divided into several divisions. For example, the top part is the engineering division, the middle is programming, and the bottom is marketing. Let's say engineering is on VLAN 10, programming is on VLAN 20, and marketing is on VLAN 30. Each division is assigned different IP addresses. For instances, engineering use 192.168.10.0/24, and for programming we use 0.20.0.20/24. For marketing, we use 30.0/24. The network are already different from each division. Therefore, each division will connect into a switch, this switch. Suppose engineering needs 10 megabyte, and for programming it's 20 megabyte, and marketing needs 30 megabyte. Because they have different requirements and networks. This is where VLANs are needed to manage these networks. So the first function of VLAN is management, and the second is to break up broadcast domains. As we learned before, VLANs function to partition or break up this broadcast domain. For example, in the engineering section, there are PC1, PC2, and PC3. If PC1 wants to send data to PC2, it must pass through the switch, which then the switch sends it to PC2 and PC3. However, the data will not be sent to programming or marketing because they are in the different domains and networks. They cannot communicate with each other. Physically, it looks like there is only one switch, but logically there are three. One logical switch for engineering, one for programming, and one for marketing. Alright, let's start configuring this in Cisco. To place PCs quickly, we can use Control and click the PC. Set up 6 PCs and 1 switch. Yes, and we connect them using a cable. To connect them quickly, we can press Control. And now we can draw a circle to categorize them. And let's label it. For this side is VLAN 10, and for the other side is VLAN 20. And for the VLAN IDs can range from 1 to 4096, but we'll use 10 and 20 for simplicity. Assign the IPs for this side is 122.168.10.0, and for this side is 2.168.20.0 and slash 24. Now configure the IPs for each PCs. Once it's done, we configure the switch ports in the CLI. So first, let's enter the global configuration mode. First, create the VLANs and name it. For VLAN 10, I name it 8. And exit. To assign a port, we use interface slash this. Or you can do multiply by using range. 1 up to 3. So 1, 2, 3. Switch for model test. Switch for test. VLAN. Okay, exit. You can check this in do show VLAN brief. See, so this is VLAN 10 and I name it 8. Do the same for VLAN 20. For VLAN 20, I name it B. Exit. 4 to 6. Now, if you send a packet from PC0 to PC1, it will send RIP request because they don't know each other yet. You can check, wait, so and now you can check the switch MAC address table with show MAC address. Ah, and to clear it, use clear MAC address table. Next, we create a second room topology with the same configuration. We create VLAN 10 and 20 on the second switch as well. Now we use trunking to connect these switches so they can communicate. Okay, we can use trunking by typing interface 7 and type switch port node trunk. Do the same on the other switch. And we can verify with show interface trunk. to show it connected. If we simulate a ping from PC0 to PC6, it 6, the switch will forward the packet through the trunk line in the other switch. So only PCs in the same VLANs will receive it. Regarding allowed trunks, by default, VLANs 1 up to 1005 are allowed. This can be security risks, so we can resist this by typing switch port port trunk allow VLAN 10 and 20. Now only those specific VLANs can communicate across the trunk. I already create the third room typology. Now we can just trunk it. This, uh, for this side is FA8. Oh, now let's look for a multi-layer switch or MLS. Now we trunk it. Oh, oh, interface. Okay, FA model trunk. Now, if you try to set a port to trunk mode on MLS, it might be rejected. This is because there are two trunking protocols, ESL Cisco proprietary and 802 1Q is open standard. An MLS supports both, so you must specify which one to use. We can use command switch port trunk encapsulation. And now we can type switch port model trunk. Now the trunk will work successfully. Let's discuss DTP. Trunk ports connect to a switch, while the access port connects to a device. DTP has a logic table, dynamic auto. To dynamic auto results an access port. However, dynamic auto combined with dynamic desirable results in a trunk. Essentially, auto waits for a request, while desirable actively acts to trunk. Now let's practice it on the switch. Check if it's default mode by typing to show show interface one switch port. The default administrative mode is dynamic auto. And let's check for the other side. Interface. If both sides are set to dynamic auto, they will become static access port. And now let's change it on one PC to switch port mode dynamic desirable. This. Then we switch port mode dynamic desirable. Okay. This will negotiate with the neighboring switch to become trunk. If one side is manually set to switch port mode trunk, let's port mode trunk. Forcing it, the other side will follow and become trunk. Check it first. Show interface. Is for the administrative mode is still dynamic auto, but the operational mode is trunk. Lastly, let's talk about native VLAN. If you look at the show interface trunk, show this trunk, you'll see native VLAN, which is VLAN 1 by default. A native VLAN handles traffic that does not need to be tagged. If a packet is sent between VLANs that match the native VLAN, it doesn't use 801 again. Okay, let's changing the native VLAN interface. VLAN interface 7 and switch port from native VLAN. We change it to 20. Okay. Exit. Now if you Okay, now if you look again, we check show interface time. The native VLAN has changed to 20. And don't forget to change the other side too. It's 7. No, native VLAN 20. Check it. Show interface. No, it's wrong. It 22. Change to 20. Uh, now, if you want to revert it to the original setting, just change it back to film 1, like this. This. Oh, oh. And switch port, terang, nah, this. Oh, show interface. Oh. It changed back to VLAN 1. Okay, maybe that's all for this material. I apologize if for many shortcomings. See you next time.